Hey everyone, welcome back. Today, we're diving deep into a critical topic for every developer and IT professional. We're going to walk through exactly how CI/CD pipelines can be compromised and why safeguarding your build and deploy processes is absolutely critical for your organization. This isn't just theoretical. This story is based on a real-world attack scenario, broken down step by step in a fun, visual, and easy-to-understand way. Let's jump right in. First, let's define what a Jenkins pipeline is. It's essentially a powerful script that dictates a precise sequence of actions for Jenkins to execute. These actions typically include checking out the repository, building the code, running comprehensive unit tests, and then executing integration tests. Finally, if all tests pass successfully, the pipeline proceeds to deploy the artifact, making the new software available. This entire process is fully automated. Developers push their code, Jenkins automatically builds it, and then Jenkins automatically deploys it. It's simple, incredibly powerful, and yet it can be extremely dangerous if even a single part of this intricate system is misconfigured. CCD, or continuous integration and continuous delivery, fundamentally consists of two primary components. Continuous integration ensures that every time new code is committed to the repository, Jenkins automatically builds and tests it. This rigorous testing verifies that the new changes haven't broken any existing functionality, maintaining code quality. Then, continuous delivery takes over. If all integration tests pass without issue, the system automatically packages and prepares the application for deployment. This means that if a malicious or compromised commit somehow enters the pipeline, it can move through the entire system incredibly fast. And this rapid propagation is precisely where attackers look for opportunities to sneak in and exploit vulnerabilities. Here's where things often go wrong: credentials. They represent the biggest weak point in many CI/CD setups. To perform its tasks, such as cloning private repositories, running tests, deploying builds, or interacting with various cloud services, Jenkins requires access to sensitive credentials. These often include API keys, SSH keys, critical production credentials, and various deployment secrets. The most dangerous practice is when developers hard-code these secrets directly inside scripts or environment files. This often happens when they're under pressure or simply in a hurry, prioritizing speed over security. The pipeline asks, "Hey, where are the credentials I need to proceed?" Developers, wanting to keep the development process moving swiftly, often take the path of least resistance. They place credentials directly inside the Jenkins file, making them easily discoverable. Sometimes, they even base 64 and code them, mistakenly believing this provides a layer of security. Spoiler alert, it doesn't. Once these secrets are embedded within the pipeline, they become highly vulnerable. Anyone who gains access to logs, build artifacts, backups, or even storage buckets can easily grab them. Now let's illustrate how an attacker exploits this critical vulnerability. Step 1. The attacker actively searches for and discovers a public S3 bucket or server that has been misconfigured to allow directory listing. They then see a list of build files, and among them, they spot a crucial file, run.bash. Step 2. The attacker opens the run.bash file. Inside, they find it, a hard-coded Git command with embedded credentials, clearly visible. With these credentials in hand, the attacker now has unauthorized access. Step 3. Impersonation. The attacker pretends to be Jenkins, sending a request to the system. They might say, "Hello FOO.com admin, here are the credentials I'm currently using." And because the system trusts Jenkins, it responds, "Okay sir, here you go," granting full access. Just like that, the attacker gains access to every single credential Jenkins manages, including highly sensitive production secrets. This demonstrates how one seemingly minor mismanaged CI/CD file can quickly escalate into a full-blown data breach, compromising your entire infrastructure. The lesson here is clear. CI/CD pipelines are incredibly powerful tools for automation and efficiency. However, they also represent a massive and attractive attack surface for malicious actors if not properly secured. Never, under any circumstances, hard code secrets directly into your code or configuration files. And never store credentials directly within scripts or your version control repositories. Instead, always implement and utilize a proper secret manager to handle and protect all your sensitive credentials. Protect your pipeline diligently, and you effectively protect your entire company from devastating breaches.